Okay, Yufan, please.
Could you see the slides?
Yes, we can see it clearly.
Okay. So today we will talk about the Coset, a benchmark for evaluating neural program embeddings. It is actually it is published in archive 19. It's not 21.
Yeah, this is supposed to be a short paper, but we would like to see more how the embeddings is evaluated and what is the state-of-the-art way to evaluate the program embedding.
Okay. So there are two others. The first is Wang Ke. He's a staff in research in Visa research, and he is interested in the program language, deep learning, and artificial intelligence. And the second is also a staff at Visa research, and his research mostly focused on program analysis to detect and characterize the malware. Okay, so I think the first staff may be expert on this field. And today we will talk 5 points. And first is the motivation. And second, we will talk about the data set. And then we will introduce 4 models used to evaluation. And then we will talk about the results. And finally, the conclusion. Okay, first is the motivation. The neural program embedding can be helpful in analyzing large software. This is a task is challenging because traditional logic-based program has limited on the scalability. And the key focus of recent machine learning advances in this area is on modeling program semantics instead of just syntax. So currently the limitation is that the metrics, there's no straightforward metrics. First, the gap between program syntax and semantics is manifested in that similar programs of similar syntax may have two vastly different semantics. For example, considering the two sort implementations, both sorting an array via two nested loops, both comparing the current element to its successor and both swapping them if the order is incorrect. Yet, the two functions could implement different sort algorithm. For example, the bubble sort or the insertion sort. Therefore, the minor syntactic discrepancies can lead to significant semantic differences. Our first requirement for the benchmark is to include sufficient samples that varies both syntactic and semantically through solving the same software task. And the second solution is to include samples that vary only in the syntactic order of statements without changing the semantics. And the third solution is to include samples with arbitrary values for syntactic tokens that do not affect semantics. So these 3 solutions are quite, obvious that, for example, for the third one, it just changes the variable name. And for the second one, he just changes the statement, use another statement. For example, he changes the while to the for. And for the first, it's like,
yeah, I still quite confused. I feel quite confused about the first point.
Pardon, please.
I feel confused. So it means you find more samples, for example, the implementation of the bubble sort, right? Or the quick sort. We can either using a for loop implementation or using a recursive function to recursion based implementation.
Yeah. So because it built a data set benchmark, so he wants the model to classify one is bubble sort, another is insertion sort.
But the problem is how to define the semantics. So
yeah,
the bubble sort and the quick sort are all sorting algorithm, right?
Yeah.
So in this case, it is much more similar. These two pieces of code or these two implementation will be more similar than some maybe the database access or network connection. This kind of the code.
Yes. But
Yeah. So let's talk more about the benchmark. so here we are talking more like the data augmentation. The data augmentation settings
yeah.
for
Use some
program,
data.
right?
Use
For
some
the
data.
program samples. And here, just like images, we want to switch, we want to revert, we want to add some noise of the data augmentation or images. For now, we are trying to transform the program while preserving their semantics. So which is more challenging than the images or text?
Yes, quite similar. He added some transformation on the program.
So, but the transformation can be automated or they still need to manually.
I think they automated the transformation.
Okay, let's keep going on.
I will talk about the.
By the way, maybe I raised the question too early. How large is such a benchmark?
How large? Yeah, I next page. It is about 84,000 programs, and it's all from a popular online coding platform, including Java, C, and Python, and they just like the lead code. They are introductory programming exercise, coding puzzles, or challenging problems. And he used 4 PhDs to label the data with 38 labels in totally like operation, semantics. For example, the bubble sort, the insertion site, the merge sort, like what I talk about. So the labels, from the labels, you can see that the semantic actually, the kind of the algorithm from my perspective.
So it's more looking to the algorithmic program.
Yes, but he also used some transformation to enlarge the data set.
So it comes to me, right? So in this case, is that possible to have a magical learning for this program? That idea just come to mind. So I think Ruofan and Dr. Xiaoyan may be familiar with this part. That means we can provide a Siamese model to learn how close two pieces of code are, right? Based on these data sets. How close? For example, we think bubble sort and insertion are closer than bubble sort and some 8 queen problem. You get my point? So if we want to, so in this case, in their benchmark, it was used for classify a code, right? Classify the program code. So if we want to classify the code, so there's a problem of magical learning. So it means that a piece of the bubble sort code can be projected into a space, right?
Yeah.
And the bubble sort supposed to be project into a closer position or closer location to the insertion sort program.
Okay.
And for the other program, like the other programs, they may be a little bit far from. I don't know. Let's keep going on. Yeah.
Yeah, I think you can use this data set for the Siamese model.
Yeah, but the question is, what can it for, and what task we need such a technique?
Because you need to get an embedding of the code, I think.
Yeah. So why we need an embedding of the code?
For the downstream task. I think it's a bit like what called BERT.
By the way, so my follow-up question is that for these 84K programs, how many classes are there?
Yes, 38 label.
Oh, 38 label. Isn't that small? So there's so many programs with different semantics, and there's only 38. And let's keep going on
Okay.
to see the data.
Okay, so the program transformations is for debugging the model and gauging the model stability. And the debugging the model is means to identify the reason of misclassification, and the stability means how stable are the models against the software variations. And there are three types of transformation. The first is the semantics approximating. And here he just changed the type names to others within the same group, like changing an API in the program to another of similar semantics. For example, they replace int with long in the group of integer types, or double with float in the group of floating point types. For the API, maybe like, the array sorts with different parameter. There are different APIs, so he can change the API name.
So that's very heuristic.
Yeah,
so let's keep going on.
Okay, so the second is semantics changing transformation. It's mostly for the fix a buggy program. So if the program is a buggy, he may use this tool. I don't know this tool. This tool to change the code. This is second transformation. And
by the way, the transformation. So how does it make sure such a change is this is for semantic changing transformation?
Yeah.
And why it need a semantic changing transformation?
Yeah, because because this data set is mostly focused on semantics.
Yeah, I'm talking about but it's more valuable for semantic preserving or approximating instead of semantic changing. Why do you need a semantic changing transformation?
Because if you change the semantic and the model had quite different result, then we can regard this model capture the semantics. He also has a semantics preserving transformation. Yeah, so this is a bit important one, and actually I don't know the details because I'm not the research expert on this field. Maybe Dr. Lin or Dr. Shaw can help me. He lists many ways to preserving semantics tools, but I don't know. Maybe anyone can.
So this is a very basic operation there.
Yeah. So,
for example, given a piece of code, if we insert a piece of data code, right, into the program, then the code will definitely be different. But the semantics will always preserve because this piece of code will never be executed. Right, and also for the loop enrolling, that means when we have a loop and we're using a for structure or for loop to do it, and equivalently, we can write into 3 nested if else, right? So we write it 3, for example. So let me write it down. So do you get my point?
Yeah, I got it.
So basically, we have a for and there's if, right? We can always turn it into the if, and we enroll it into maybe 10 times. It's almost like the loop will be executed for 10 times, right? Based on these transformations, they try to preserve the the semantics of the code.
Yeah, I think so. This approach are all the basic ways to preserving semantics, but do some small transformation. Okay. So any question here? Anyone? Okay. So now we go to the 4 models. So I have talked about the data set. The original data set is from the online competition, and he also do some transformations on data set to enlarge the data set. And here is the models this paper used to evaluate. And we may short introduce the four models. The first is the 3LSTM. Just look at the right picture. The original LSTM is follow a sequence, and now the LSTM is follow a tree structure. So you can just change the one neuron, the statement of one neuron to like accept the information from different subneuron, and then you can get a tree LSTM. And then for the graph, gated graph neural network, he used the data flow as the edge of the graph, and he used the S tree as the base of the graph. And if there is a data flow between one node and another node, they will passing the message. So this is the graph neural network for the program language. And for the last one, the S tree based, he used the attention. Here, if one node and another node is linked in the S tree, it will have attention, or they will not have attention. So this is based on the attention, and based on the path attention. The path is actually the AST path. So this is the AST path attention network. And the last one is the different, quite different. It's not use the code tokens to use the execution state, and he used execution state to embed and use RN to capture the high features, and use polling to this is the whole structure of this model. The most important thing is that he used execution state, not the code token.
Can you raise an example of execution state?
For example, if you have a bubble sort, maybe the original number is quite different, like 3, 4, 2, 1, and then you will.
So basically, you are using the array valuation, right? Now how the value is. But the point is that if we change it into another program, its state will be looks extremely different.
Extremely
very different. For that means for the sorting algorithms, it's quite understandable that the state is actually the variable ranking, right? The variable ranking here.
Yeah.
Right. So but the point is that how do we encode such a state? And what if the sorting variable is string? The string, for example, we want to sort it sort it regarding the length, or sort it regarding the alphabet order. And how does it change accordingly? How does the embedding change accordingly? Or we want to, or sometimes we want to sort the student and object, right? We want to sort based on student ID, or student age, or student height. And how do they identify such a specific state? And also such a state will actually change during the execution, right? So even for this 3, 2, 1, 5, etc. And then after the next sorting step, it will become 2, 3, 1, 5, etc. And how do we how many snapshot of the state will be recorded?
Actually, this is part of this paper, and this paper actually is the same other of today's paper. So he published one model and one data set, but separate to 2 papers. So
no, I'm talking about what you show the architecture here.
Yes,
I'm asking the architecture.
Data set is designed for the execution state is like the array, so not considering your situation.
No, I'm talking about array per se. So you can think about it. So you're thinking the execution state, right? Yeah. So how do you define the execution state?
Uh,
How do you define execution state? What and there's a lot of the questions following up. So when you have slides, you somehow need to prepare those questions.
yes, but I think it's not today's papers talk about because
Yeah, I understand. See, basically to provide a benchmark and evaluating all the models and very likely that they criticize all existing model are rubbish, right? So maybe that is what they want to talk about. But the point is that given this model, what is the rationale of such a design?
but he didn't. This model is not in this paper. It's in another paper. So this paper didn't talk about this model.
Yeah, but the point is that we want to understand why is the performance is poor, right? And also you say that this is execution state. So maybe if you not understand, you can just pass this. So let me go back to questions. Do you know what is execution state?
From my side, I only regard this as the the result state.
Result state.
Yeah, the
No, you talk about what you can confirm. So I just feel quite weird.
Oh, no,
about it.
no, I didn't confirm because I
Right.
actually don't know. I didn't read this paper, so I don't know what is the
Okay, we can pass. So because if we're talking about because you're talking about execution, when talking about execution, to somehow leads to the dynamics about the dynamic aspect of the program. That means we need to run the program, right?
yeah.
Unless we run the program, we can get the value of 3, 4, 1, etc. And if we run that, how many intermediate state do we need to record, and how long the trace it is, right? And which variables do we take into consideration? That is all the follow-up questions. So I think if they want to do this, and also it is why I'm keeping asking this part. It is because this work is very relevant to Xianghui's research. Because in the future, Xianghui may also work on the embedding of the execution, but this is a very challenging work. So if someone have pioneered on these areas, it's good for us to take a reference.
Okay, I quickly checked the original paper. He said that the execution trace is triggered by random testing. So he just recorded the program state based on the variable valuation, the state of the memory. So he just, the variable valuation. So
So this is still very ambiguous statement. And if we concretize all the details, for example, when the program is in a loop, that means it will be executed for a while, and how many intermediate state, and how many the variations of how many variables should be recorded, right? And how long is the trace should be considered, and which variable matters most, right? So that is all the unanswered but a very important question.
Yeah, I think he just follows the all the variable. Because he didn't talk about this in the paper.
All the variable, that's supposed to be huge.
But the code is not huge. It's just a simple code. I have just mentioned he is from the online computation.
And what if the array length is 1 million?
It will, yeah, I think if the array is too long, very long, then the execution will be very long. So maybe the random test is designed so it's very short. Because you need to.
Okay. So where is this paper published?
I don't think it's published.
It didn't publish.
Yeah.
Okay, let's keep that. Okay, we do not linger on this part for too long. Let's move to next step. Next slide.
I think these two papers also do not publish. It's 19.
Let's keep going on. Yeah.
Okay, so now is the evaluation results. You can see that the last model is the best. And the other metric of interest is scalability in terms of the program size. So he used the bytes. He considered he unifies the program size dimension as number of bytes with a line of code being on average 15 bytes in length, and a trace state changes to 20 bytes. And you can see that the accuracy quickly drops as program size increases. So the past three model losing all accuracy, while the last model still have the 60% accuracy. And if the program exceeds 100 lines, it will lose all the accuracy. Any question about the results? The others said that because the last model operates on execution traces, so it will be better consider the program size.
Definitely. So that means we randomly change some statement. The model does not care about it. The model only care about the runtime variable value, right?
Yeah.
So
yeah.
as long as the runtime variable value is preserved, the semantics is preserved, no matter the data code, no matter about the refactoring, etc.
Yeah.
Okay, let's keep going. So there's nothing surprise.
Yes. Okay, so he also do some analysis on the detailed example. For example, here the left figure is misclassified by all of the static models. The static model is the foremost three models, and the last model is the dynamic model because it uses the execution traces. So the error is due to the variable, the float, and the right picture is also get a very low accuracy because he just changed the core and the row position. In our human eyes, the core and the row are all the same, but the program will regard them quite different.
So the point, so I didn't understand. So the change, you mean the based on the perturbation, the model has been attacked.
Yeah.
Right. So for the first code, we just change the
float.
Change the float type into
double.
Is double subtract, so the model is effective. And for the second piece of code, we just change the position of column and row.
Yeah.
But the point that how do they now changing two variables can still preserve the semantics manually or automatically?
I think this is manually because he used some detailed examples. But the float double I have just mentioned the transformation. Yeah.
Okay, so this is a very interesting about a program augmentation. Let's keep going on.
Okay, and for the syntactic structure, the paper said that the Coset exposes an uneven distribution, because the program language is uneven. Sometimes like the keyword in the some int, this word will be popular, and this word like switch, the program may not, the model may not see this token. So in that case, the others said that the switch statement is the reason of the error. So in other words, the models would have to correctly classify the program if the switch is converted to a if else. So because if else is a far more popular selection statement.
Let's keep going on.
Okay.
So the program, I'm not sure whether the program classification really makes sense because I'm not sure whether, and maybe it is for teacher to assign the coding to scoring, for a teacher to score the coding assignment to make sure to give it a score of how good the program looks like. But usually people, the teacher score the program assignment based on the test case, right? How many test cases you can pass.
Yeah.
And also make sure the program is not a hard-coded program.
Yeah, maybe it's for build a better embedding. So he uses downstream task to let the model get a better embedding. I don't know also. And for the last, then the Coset discloses issues among static models in generalizing the API calls. You can see that there are two examples. The left one can be fixed by replacing the underlying API with array sort, and remove the parameter. And for the right one, it can be fixed by removing the elements add to like this. So this paper said maybe it's because this model didn't know the API.
Let's pass this one. So this one is not something important.
Okay, so this picture depicts an example that is misclassified by the AST path neural network and the tree LCM. By removing the if clause at the beginning of the function, both models produce the correct result. So maybe actually I didn't account. The paper said, oh sorry, the paper said this is because it has the error handling. Any question here? Okay, so then we will go to the buggy code. The Coset reveals that the last model as the most successful model. The reason being the dynamic nature of program representation adopts. That is because if there's a bug, its runtime dynamic trace will likely lead to great discrepancy than the syntactic representation. So for the bug code, the last model will not that success. Any question here? Okay, so for semantic property, they said that, for example, here, this picture, they will trigger a misclassification of this kind on all static models. The other thought that it's because it's a different bubble sorting. So if you change a little on the structure, it will get misclassification.
Okay, let's move this example. So basically, it wants to show that this model is very vulnerable to the semantic preserving transformation, right?
Yes. Okay, so now it evaluates the scalability and the stability, and you can see here is the percentage of changing predictions when applied semantic preserving transformations, and this is what we have talked before, and here is the question: why the last model gets 0% accuracy loss?
What is a transformation, right? So VR is kind of transformation.
Yeah, this is a variable, rename. Variable rename. So these are all software refactoring. So why the last model didn't change the accuracy, didn't lose accuracy if they just change the variable name? Any volunteer?
Hope people are still following you. And Chen, do you want to have a try?
Hello, Yuchen.
Actually, I just came back from the toilet. I'm not sure. What did I miss?
The point they're asking that, so there's a deep neural network model. It's going to automatically classify the program. It will really classify a program as a sorting algorithms. It will classify them into maybe a puzzle program or a buggy program, whatever it is. So, but in order to evaluate the robustness of those neural network model, is trying to apply some semantic preserving transformation on original program. For example, given a program, you're going to add some data code into it, or add some obfuscation on it, right? So when we add those kind of transformation into it, and some of the model will have their decrease, some accuracy decrease. But the problem is that the last technique or the last model is not affected by such a transformation. For example, when we're refactoring the code, right? When we're refactoring the code, after the code is refactored, all the previous three models have their accuracy decreased, but the fourth model does not. Can you have a guess why there is a technique, the model is so magic, so that any software refactoring transformation will not affect its model accuracy?
Okay. So I guess it's because they don't actually use the, how to say, like the plain program. It does not really depend on the plain program as its input. So
yeah, a very good guess. And what kind of the other, but it must depend on something, right? So what do they depend?
right. So just now I think Yufan gave a hint. So it's the execution trace. And I guess it's like I guess after you do the compilation, the things like variable name is lost. The information is lost. So it
yeah, so I think that's a very good answer.
Yeah. Okay, thank you. And then we will go, finally we give the takeaway notes. First, the final mode get the best result because the paper thinks that is use the dynamic execution traces, not like the static model use the tokens, and the static models are much less stable against the syntax variations, even when the semantics are preserved. So if you carefully use this dataset debugging features, we can identify a number of specified shortcomings in the tested models. So that's all. Thank you.
Okay, thank you for giving the presentation. And one comments is that, will please go back to still share the slides. Let me finish my comments here.
Okay.
The first comment is that, especially for, I suggest that you share the last approach in the group so that we can have investigated how the runtime execution. I think that will be, Xianglin will be interested on that part. My second comment is that, have you ever heard about obfuscation? The technique called code obfuscation. Hello, Yufan.
I didn't.
Yeah, so the idea, the idea is called obfuscation. Obfuscation. So maybe that is maybe that is spelling. So the idea is that in the security, especially in JavaScript, have you ever learned JavaScript in your undergraduate course?
Pardon, please.
Have you the JavaScript?
JavaScript? No, actually.
The idea is that one of the undergraduate students would. So at that time, a lot of web pages. So web application development is very popular, but the problem is that when you download a web page, and all the JavaScript code is just there. So if they're using JavaScript to perform some checking, for example, if you want to import something, it's all the checking logics minifier, something like that, but I'm not that familiar with the minifiers. So the basic idea is that if we change the logic of JavaScript, and it allows us to submit some information, submit some illegal information. Basically, if we want to using some secret injection, if they're using some check to see whether your input variation or expression is somehow related to the secret injection, and if we change that part of JavaScript, it will just remove, will not allow you to input such information. So from the front end, there's a lot of the code about their technical code obfuscation. So it will randomly add a lot of noisy coding to it, and change the variable into A, B, C, D, X, Y, Z, etc. to make the code harder to understand. So that is almost the reverse of the software engineering. From the perspective of software engineering, we need a code more understandable. But from the perspective of security, we want the code less understandable. So now you're working on the comment generation, right? The comment generation, I'm thinking about it, maybe that is a new idea. Maybe that's an idea for a new evaluation. Is that nowadays a lot of the comments generation, a lot of comments is generated based on a method body, right? So now our idea is going to use content or context to complement the generation. So maybe another idea for you to work on is that what if the code has been obfuscated? So that will be applied on the security setting. That means when the code has been obfuscated, is that possible that the obfuscation, we apply the obfuscation and the generated comments for the obfuscated code? So this is another idea, you can think a little bit about it.
Okay, thank you.
Okay, but what matters most is that we will first finalize existing work, and hopefully we can have a submission on January.
Okay.
Okay, next one, how about Xianglin?
Okay, wait a second. Oh. So I'm going to present extending deep learning representations by tracing the training process. And this paper is submitted to AAAI 22. And at first I wanted to suggest that maybe we may not lingering around some details for this paper, because really I think their paper is not that well written, and some details, even myself, I'm not so sure. And the authors are from TU Dartmouth University, and their research are around the machine learning and statistical learning theory. So the background of this paper is that currently we have some model explanation method, and some of them focusing on explain individual samples like the salient maps and breadcrumb that we mentioned before, and some work focusing on model abstraction. That means they use a simpler model or one explainable model to locally approximate the complex model. So that's what they do. And for this paper, they also wanted to answer the question how to track causality. And more specific, the question is, why did the model learn to compute this output? Overall, their contribution have 2 points. The first is that they identify and show the most influential training examples. And the second point is that they visualize all the training samples using some rigid plots. there, I'm not sure what they meant by this motivating example because they didn't explain on the introduction part, and for those 3 lines, I find it hard to understand. But maybe we can skip this part, and later we will know what this rigid plot means. So first, they started from the stochastic gradient descent method. So usually, if we define a loss function and the loss function is defined over all the training samples, and each update step is based on the gradient of loss, right? So that means they select the t training points and update the model weight based on the gradients of loss. And then after one epoch, they summarize all the weight changes after seeing training samples. Do you have questions?
So that's very basic idea.
Yeah. So first they introduce this setting, and then they wanted to use this to extend the pre-activation. And here, normally, I think the normal pre-activation means some work put the activation function before updating the weight. But here, what they mean is just the WL times
previous layer.
Yeah, so that means
previous layer.
the output before activation. But so here the WL means they summarize all the weight updates after seeing those T samples. And then for each, so here they assume the layers are all linear layers, and for simplicity, they omit the bias term. And then at each L layer, it can be computed like
T is the, sorry, so maybe I missed something. T is the sample.
T, yeah, T is the T training sample.
Okay, it's an individual sample.
Yes. So the delta T means the weight change after seeing T sample.
Yeah, so then I have to compute why the W is actually, so it's delta W or WW.
Which
delta,
one?
What I mean is this is let me annotate. So my point is that this is a delta WL or WL. So this delta,
no, they denote WL as summing all the weight update after seeing T samples.
all the way. So supposed to
So from this picture,
there's supposed to be W. So the W is actually the change.
Yeah, the change. Yeah, correct.
Oh, it's a change. Then it will.
Yeah, this part I'm also confused. I feel confused, but.
And these two W are these two W the same W?
Yes.
The same W. So if I understand
I'm also confused about this part, but that's what they write in the paper.
This W is actually the weights on the L layer, right? The L's layer. And this W is actually all the incremental change on the weights. But they
didn't talk about this. They just denoted WL as all the weight update. So maybe they are the same or not.
Really? Are they really the same? I think they're totally different stuff. I think one of the answer is that this W plus W0, the W0. Right? I think then we extend that makes sense. But I don't know how.
I'm not sure. So
right, there's a time before that, because this delta is what we achieve in this epoch, right?
Yeah. So
And
they would accumulate the weight change through all the layers, right? Really, I'm not sure, but
okay, let's keep moving on. But
yeah.
whatever we understand,
Mm.
apply the gradient descendant and we achieve a new W.
So the FL minus 1x is the representation for
The
sample
last
X,
layer,
right?
in previous layer.
No,
Right.
oh yeah, in the previous layer. So they times FL minus 1x on both sides of the equation and get this. And the visualization is like they go all the way up to from the first point to last point. And then they wanted to, yeah, again, here is my understanding is that for any given point X, they wanted to compute which samples contributed most for reshaping its representation. So they wanted to select top K samples from those chaining samples, those T chaining samples. And here they just use the cosine similarity, I think, even though they say something about they do some inner products and whatever, but the equation is just cosine similarity. So they just compute the overall change for one epoch and then with single step.
So get rid of
they
the
compute
equations. Get rid of the equations. Can you provide a rationale and how do they select the most influential samples?
So because the weight update can reshape the representations, right? So they compute the similarity between the overall update with each step. Like for example here.
Each
this is
individual
one step.
sample or each step?
What do you mean by individual? So the input X is set. So it's fixed, but they want
okay. This X is not a sample, it's a
X
sample.
is given, right?
X, and my question is X is sample or set?
Sample.
Is individual sample.
Yes, so for one given sample, I think from my personal understanding is that they wanted to find the most influential training points to influence the representation of X, right? So here they have T step, and each step is a vector. The update of each step is a vector, so they compute the similarity between the overall change and each step. Can you get the idea? So here, if for example, if we have T
but
samples,
a more straightforward answer a question is that isn't X is the most influential sample for itself?
But it may not be the training sample.
So you mean that X is the testing point, the testing sample, not the training sample?
So they wanted to find the most influential training point to reshape the representation of X. I think that's their idea, but I'm very confused.
In this case, it has to record every epoch as well, right?
Yes, so their storage overhead is quite large.
Okay.
So I think it's pretty clear. So they just compute the cosine similarity between each step.
Okay. So that's clear.
And then this is their algorithm. So for a given f function and x and some weight update, so they record all the weight update. They initialize the influence as 0 and then compute the value. and iterate over T training samples, and finally they get top K indices from the list.
Okay.
But here, I think one never mind. And then the second setting is the mini batch setting, because usually when we train the model, instead of using one sample to update the weight, we would use the mini batch to update weight. So after performing one step, it's difficult to set contribution to all the samples inside the mini batch. So what they do is that they first set all the samples to be from one class in a batch, and then make all the contribution inside this mini batch to contribute it equally.
I somehow get a bit confused. So the samples in different classes, why the classes of the samples matters?
There is later in the paper they explain why they try to do this is that when they use different the samples from different classes, the result is not good. So
Let's keep moving on. So I think one of the very good takeaway is that this is also aligned to our intuition, is that the prediction is constructed based on some samples, right? And how and a good evaluation of the influence of the samples with each other, I think that is very important. And I think so. How influential a few samples are to a given sample, especially for a mispredicted sample regarding the model architecture. I think that is a very good causality, a very good angle to think about the causality.
Anyway, so another challenge come up, because when you set all the samples to come from one class, then the batch normalization will be biased. The intuition here is for the normal mini batch normalization, it should look like the first graph. And then if all the samples comes from one class, then it will be wrong. And their solution is that they will inject some ghost samples for the batch normalization step, and then later for the weight update, they will just remove the ghost samples. And the whole algorithm explains how they compute mu and sigma for the batch normalization step, but they also didn't explain why they designed the mu and sigma update like this.
And we can skip this, but I think we need to back up. I think there's some in this work also provide something interesting. Indeed.
And then apart from examining some individual sample using them to show the most influential samples, they also show the overall contribution as rigid plots. Why they do this is that they saying for some privacy reasons, it would be better to show the overall results. And then for each so here they have 10 rigid plots for 10 different classes. And for different classes is that they provide the this value, the gamma LT. So the similarity between, the importance score they compute here as the value and show them as histogram plot. And if the similarity, so is larger, then that means at this layer, this class contributed most, something like this.
So
Because-
the X is importance score, gamma T,
Is the yes,
YX.
because the importance score is the similarity, is also the similarity score, right? So if your update is consistent with the overall step, then they think it contributed most.
So, but there's nothing special. So
nothing so special.
but the point is that I think it's good to know with this matrix and with such of the rigid, this a rigid graph, right? So it's good to know this rigid graph. But so what? But the problem is there's a so what question. So
So then next
even
you
if
should look at the experiment.
no, I'm asking that. So this is the end of the proof, right? Is that the end of the proof?
Yeah, that's the end of the
I think this is the end of the proof. So, we wanted, so given training data based on the historical training process, definitely can know what kind of the training samples influence these testing data better. So that's interesting as angle or perspective. But what can we do based on such observation? Remove those training samples or? But
Let's look at
whatever,
the experiment.
let's look at it. But I think the inferential and the causality is also, I think the causality and inference are quite entangled concept. Yeah. So based on based on the scenarios where we can raise this question and bring us more insightful conclusion. Okay, let's think about it. So whatever it is, so the idea, the takeaway is that during the training process, it will record it how each sample exert or produce the inference so that it results the embeddings of the final, right? It's about embedding, the embedding of the given individual. Or let me rephrase that is giving an individual testing samples. They want to see and how the samples is the dynamics of the embedding of such samples and which training samples or which training data will have most inference with are most inferential to cause such a dynamics. Okay.
Yes. And for experiment part, first they apply their method on image classification problem. This model is VGG16 on Semantics data set. And for this, remember that you're just talking about the storage overhead. I think the main reason why they only train it for 35 epochs is that they really need to store a large amount of.
So do we.
Yeah.
We still need to store a lot of the data, right? And also models.
But not as much as them. Because just for the disk storage demand, they need 1.5 TB for the
The reason is that they need to store all the inference generated.
Because for each step, they need to store the model at each step.
I'm thinking about it, the data is computable, right? I mean, the inferable. There's no need to, as long as the data, the model
But
is
they
stored.
need to store the weight difference.
No need, right? So do they need? So they need to store each batch, each mini batch, right?
No, here this is for the stochastic descent, gradient descent.
Yes.
So
yes,
each time the weight update is associated with only one training sample.
Yeah, I understand this one training sample. So my question is that whether they need to store for each epoch or they need to store whatever they need to store a snapshot of the model for each epoch or for each mini batch.
They have two settings here.
I think it's for each mini batch you need to store.
So
It
that would be
depends on
huge.
which-
So that would be huge, right? So mini batch will be about 200, and if there's 50K, which means there's 200. Yeah, there are 200 snapshots for each one epoch. So 35. Yes, for 35 epochs, they need to
Or 50K.
store, right? 50K, right?
Divided by.
Yeah, so I'm saying that it need to store 7K model snapshots to finalize to do this experiment. Hello?
Mm.
Okay, let's keep going on.
So from this experiment, they just the first image is the reference image, which means the given sample, and the last 7 images are the most influential training points.
How do they know it's correct?
So they are all cars or trucks.
No, there are other cars. Why other cars cannot be influential? How do we know the ground truth?
Mm.
I think if I'm the one who do the experiment, if the model report these 7 images as the most influential one, and we just remove these 7 images, more like the concept of philosophy of Shapley value, and we retrain it, right? We retrain it, and also comparing to the retraining results. Of course, we retrain it and get its representation layer. So then we remove some random 7 images and to retrain it to make sure that the removal of these 7 imaginable or assumed most differential samples will cause the largest change compared to the originals in samples. But that is a more straightforward, intuitive way. But for now, there's no ground truth. I just feel a bit weird.
And then for the rigid plot, so they just show that with the depth of layer to go deeper, it shows that the model learns more of the first class because their distribution, the mu of this distribution.
Yeah, I think the overall it is kind of a little bit superficial about the understanding. Yeah, and but definitely I think the philosophy, the idea is definitely correct. When so think about it, when the deep neural model is learn the representation, right? So we want to know how this representation is formed. In this case, there's a different way. For example, the learning rate matters, the architecture matters. Some, for example, the architecture means that whether we have some residual layer, like ResNet, and whether the feature map, the design feature map matters, and the training data map matters, right? So we want to know which one will consider which one is most influential and how such influential is propagated along the training process to form such a representation. And especially when we find that such a representation is not satisfactory, and what can we do to modify the model? So the first step is to locate the ringleader or the root cause to form such representation. and comparing to the program analysis or the program debugging. So program debugging that we find the code is wrong, and we miss a check of the non-point exception, or we miss the check of the boundary, then exception happens. The model usually involves some trade-off or sacrifice. For example, the model is mispredicted because, the sample is mispredicted because the model want to have a trade-off to favor the other samples. If we can have such a big view and present or visualize such a trade-off, that will also show a lot of contribution. Okay, let's keep going on.
And then another application is on graph classification problem. And this formula describes how to update the graph neural network. And here they also have this WL times phi UV format. So this is consistent with the previous description. And the reason why they didn't show individual samples here is that they said this requires a lot of domain knowledge and the graph node is too complicated. So they just show the rigid plot. And here, they're saying that I think there's a mistake with the labels here. The second plot is the 14th layer and the C is the 12th layer. But based on this result, they wanted to show the deepest. Oh, sorry. Anyway, it doesn't matter which layer it is. They just show for the 12th layer, they found out there is no much difference between different class. So after seeing this result, they removed the layer of the last plot and trained the model again and found out that the test accuracy didn't change much.
Okay, let's move on.
And lastly, they show the training overhead. So this storage demand is I guess is the largest difference, and some relative overhead of runtime.
Okay.
So basically, that's all for this step.
Yeah, I suggest that for now, some information provided, for example, the inferential analysis or the impact analysis, it is definitely a very important concept. But it is important. It will be important. It will be more important in two aspects. In two aspects. The first is that under what scenario we need that information, right? For example, what I see there's a misprediction, or there a batch of the samples are mispredicted, and what is the ringleader and what is the root cause? Definitely, we need to use some inferential or inference or impact analysis for that. On the other hand,
do you mean for different applications?
I mean, it's more like the photo localization, the idea of the photo localization. So when those part of the data of this part of the samples are mispredicted, we want to find the ringleaders. We want to find the root cause there, right? So the inferential analysis and the impact analysis are definitely the way to go. And the second to make it more important is that when we apply the impact analysis or inferential analysis, we want to know the so what action. So when we know that this part of the actions, this part of the samples are really inferential, or maybe actually the inferential analysis may not just apply on the data, training data, but also apply for some model structure. So if we can infer sometimes learning rate is a problem, or sometimes certain other hyperparameter, maybe the model architecture is a problem, we can further locate it, right? And so this information, so these are different categories of the inferential analysis. But once we identify the inferential, for example, certain training data is really inferential, and maybe we find that the class imbalance is the most inferential reasons for our worst performance and what is the action we can do. So this is another way to do. So if we have input analysis and followed up with a remedy or the mitigation solution, so that we even more the contribution will be even more significant. So, but anyway, so today's comments, I feel I just provide a little high level, and hopefully we can crystallize them in our own research.
Do you think this is somehow
Useful.
yeah. So for this part, because
Dr.
they really
Xianglin
provide.
wants to analyzing the layer presentation for the self-checker work,
Oh,
but I'm not sure how it will be. But definitely it will be useful somehow. But how to integrate into your work? I think that is I'm not sure. And also this work, the intermediate representation, sometimes used for, sometimes I haven't seen this through.
yeah, but anyway, so
Okay. So it's good that we have quick meetings. So thanks, Yufan and Xianglin, for their presentation. Is there any questions for their report? Okay, if there's no other questions, let's call it a day. Thanks everyone for the attendance, and thanks Yufan and Xianglin for the presentation. Okay, bye.
Bye.